All right, Dr. Lane. So this question is coming out the homework. This is for Newton's second law, number 93. It's even got a little star there. That's what I'm talking about. Okay, it says two blocks, masses M1 and M2 are connected by a massless cord if the two blocks are pulled with a constant tension on a frictionless surface by applying a force of magnitude T2 to a second cord connected to M2, a mass 2. What is the ratio of the tensions in the two cords, T1 over T2 in terms of masses? So this is our diagram they gave us right here. So here's my homework page. So I started off with the diagram they gave us right here. You see a mass 1, tension 1, mass 2, tension 2. I decided to separate these into two free body diagrams. So the first one, I drew all our forces. We have mass of 1, see this is M1 and M2. So we have the gravity of M1G. You have tension, T1 pulling in that direction. You have a normal force going up. So then, this is number 2. So we have tension 1 right there. We have the gravity of mass 2 times gravity, which is right here for the bottom one. And then we have the normal force, N2, and we have the tension, T2. So we know that this is a frictionless surface, so we have no friction force fighting against us. So that brings us to what we do next. So we want to do the sum of the forces in the x direction for both of these because we're not worried about what's in the y direction. We just need to know what's in the x direction for this problem. So we do the sum of the forces of f of x1 equals the mass times acceleration of mass 1 times acceleration in the x direction equals T1. I'm sorry. So after we convert this problem, our answer for this sum right here for this is AX equals T1 divided by M1. So then we do the sum of the forces in the X direction for the second body diagram, this one. So we have sum of the forces in the X directions for diagram 2 equals mass 2 times acceleration in the X direction equals negative T1 plus T2. So we want to convert this. And what I did was, since we know the first A right here, we're going to plug that acceleration in right here. So we get M2 equals M2 times T1 divided by M1 equals negative T1 plus T2. So I brought this to the back of my page to finish up what I was doing. And so this gives us the equation of M2 times T1 over M1 equals negative T1 plus T2 again. So I worked it out and I got my solution. So we go then it's M2 divided by M1 times T1 over T, which equals over 1, which equals negative T1 plus T2. So all I did was I just multiplied them to get M2 over M1. And then, so now we have M2 over M1 equals negative T1 plus T2 divided by T1. So then we come down and I did M2 divided by M1 equals negative T1 divided by T1 plus T2 divided by T1. And that gives us M2 divided by M1 equals negative 1 plus T2 divided by T1. So then we come here and we get M2 divided by M1 plus 1 equals T2 divided by T1, and which converts to our next equation, which is T1 times M2 over M1 plus 1 equals T2. So then we come here, and the problem is we need our answer to be T1 over T2. So we get T1 over T2 equals 1 over M2 divided by M1 plus 1. So then we have to multiply everything by M1 and M1 to get our final answer, which is T1 over T2 equals M1 over M1 plus M2. And that is our final answer for this Newton's second law problem.